Unfortunately, the 7K, the control unit that we have, the signals back and forth between it and the new repeater are at different levels, and then the equivalent signals going to the old GE radios. So I have to get inside of the controller and do some physical modifications to make it work with the new repeater. So if you happen to try to get, especially the 449.35 on Squaw or the 147.33 at Station 4, either one of them online suddenly disappears for a short period of time, don't panic. It hasn't disappeared. It's just in limbo for a while until the solder smoke clears.
Gotcha. Excellent. All right. I can read off, I guess, from the president's message from Kevin Schmidt from our latest roundtable. Greetings and salutations. He hopes that they're enjoying the milder weather in Denver. Normally, we expect to get better cold during the stock show, but we escaped wrath this year. Certainly can use the moisture, but they prefer any snow that falls remains in the mountains where they don't need to shovel. Denver Radio Club recently held its monthly board of directors meeting. We discussed the normal items such as the minutes and treasurer's reports. We also brought up ideas for activities that the club could participate in this coming year. The DRC Saturday events have been popular, as well as Field Day last weekend in June. Board of Directors also brought up such events as participating in the ARL W1AW/0 week-long event, or Colorado's 150th statehood celebration. As much as we, the board, think of ideas that would involve members, we can't think of everything that's on your lists. If the club isn't offering items that interest you, please reach out to either Pete, AB8WN, at W0TX.org, or Brian, KF0AWC, at W0TX.org. They are heading up the Membership Involvement Committee and soliciting ideas. As mentioned, ARL, in celebration of America's 250th celebration, is having each state take 2 one-week blocks to activate their portable station. Each state has a 1-week block in the first half of the year and another in the last half. Modes include single sideband, digital, FT8, CW. If you're trying to get worked all states, this is an opportunity to achieve that goal. A list of their states and their week-long block, which starts Wednesday, and runs through the following Tuesday, can be found arl.org/America250-WAS. And not wanting to sound like a broken record, but we are always looking for 1 or 2 net control operators to host the Sunday night net and Wednesday night nets. Sunday at 8:30 and Wednesday at 7:30. Club has a script that guides one through the net. If you can do it, if he can do it, he knows that any club member can easily perform. So if you hold a technician level or higher license. Lastly, don't forget the Arm Ham Swap Fest happened on the 15th. So that sounded like there was a lot of good attendance to that. So that was from our president, K0KPS. So at W0TX.org for more information on our club. Roundtable by Brennan Pate, AD0UZ, and a lot of contributions by Bill Rinker, W6OAV. So check that out. It's certainly not behind any paywall and probably won't be anytime soon. There was an update on our website issues, so that has thankfully been resolved. And just some other news and articles. So I'll throw it out to the group before we get started. Comments or questions about our club or any operations or repeaters or anything else?
Just a quick plug again for the Membership Involvement Committee. Thank you, Bob, for responding to the email. I got a couple responses, so I'm going to throw it out to Groups.io. A couple of people that said they wanted to be part of it. I haven't heard back, so I'll put it out there and pick a date, and we can get together for the first time for that involvement committee. So look forward to that on Groups.io. I'll get that out tomorrow morning, and we can do that. So that'll be good. But if you would like to join, just let me know. Again, obviously in the notes for the roundtable, you can find me, AB8WN at W0TX.org, and just reach out to me. Thank you.
Excellent. Thank you, Peter. groups.io/G/W0TX. Lots of involvement there, so appreciate everyone participating in that. Anyone else before we get started? We're going to play a video about GPS jamming, about 36 minutes.
I think I saw Kevin pop up in here too. So the president
Sorry.
is present, I think.
Yeah, the president's traveling right now, so he doesn't have any words of wisdom tonight.
No problem. Well, safe travels. All right. Any more comments, questions about our club? Otherwise, we'll get stuck into it. Okay, this is a pre-recorded video. Don't hesitate to ask me to stop it at any given time. If you have any questions, feel free to raise your hand or put it in the chat or just jump in on the audio. Who cares about the Baltic Jammer? Terrestrial navigation in the Baltic Sea region. Fran, go ahead, please. Yep. All right, just testing it. Okay, no worries. Yeah, you just have to click on the hand if you want to. Can I put my hand down? Okay. Yep. Hopefully everybody's audio is working. Hopefully everyone can hear us and see the chat. If you're not used Google Meets, let us know. Reports of GNSS interference in the Baltic Sea have become almost routine. Airplanes losing GPS, ships drifting off course and timing systems failing. But what happens when a group of engineers decides to build a navigation system that simply doesn't care about the jammer? Since 2017, they've been developing R-Mode, a terrestrial navigation system that uses existing radio beacons and maritime infrastructure to provide independent positioning, no satellites needed. In this talk, they'll share their journey from an obscure research project that nobody needs to a system now seen as crucial for resilience and sovereignty. Expect technical insights, field stories from ships in the Baltic, and reflections on what it means when a civilian backup system suddenly attracts military interest. Make sure it's all unmuted.
Thank you very much. My name is Niklas. I work for the German Aerospace Center and the Institute of Communications and Navigation. I work in Neustrelitz, which is in Mecklenburg-Vorpommern, not very far from here, in the Nautical Systems Department.
Me too. Okay, yeah, I'm Markus. I also work at the German Aerospace Center, but in a different department, so I'm located near Munich at Oberpfaffenhofen.
And yet we all work together.
Yes.
So yeah, thank you for joining our talk. I think the introduction was already given, and I think most of us remember this kind of nice picture. So we called it the Phantom Menace. So I just put a few headlines there to just showcase the media reporting of the past 2 years, because what we have been observing in the Baltic Sea area for the past almost exactly 2 years now is significant GPS or GNSS, so navigation satellite system jamming and also spoofing. So the picture in the background is from gpsjam.org and is based on ADS-B airplane data. And this has had some significant impact on shipping and air traffic. So we had airports temporarily closed, and also some minor and major incidents that were concerning vessels. Because a very large number of systems that you will find on an airplane or also on a vessel are depending on GNSS data provision.
Yeah, so now I take over because the main question is how we can do this. And funny enough, in 2015, the Chaos Computer Club gave out these little devices. You might remember the radio, a software-defined radio. It's not only a nice name tag, you can also send GNSS, which is a general term for GPS, signals with it. You just need to have this or any other software-defined radio. Download a GitHub repo called GPS SDR SIM, and then you have an antenna, most likely also an amplifier to get a bit more range. And then what you see in the picture is I generate some signals, have a small GPS receiver, and we see we are somewhere in New Zealand while I was in Hamburg in my office.
Yeah, so we all learned now that GNSS jamming and spoofing is quite easy. I think most of the people in this room could probably do it easily. The hardware is available here. And regarding the Baltic Jammer, the question is, okay, what is happening in the Baltic Sea? And since we are just simple researchers, we are just quoting other people who tell us what is happening in the Baltic Sea. So the German Federal Ministry of Defense told T-Online in April last year that the ongoing disruptions to the global navigation satellite system are highly likely of Russian origin and are based on interference in the electromagnetic spectrum, among other things originating in the Kaliningrad Oblast. There's also been more deeper going investigation by GPS Patron and the Gdynia Maritime University. And the report was published in November 2025. So they have analyzed the disruptions, especially in the port of Gdynia and the Baltic Sea region and the Bay of Gdansk. And they found that there's multiple interference sources that are active at the same time, and they are forming a coordinated jammer network. But there's not only GNSS wideband jamming, there's also some persistent GPS L1 spoofing, which means that the signals are also manipulated, and we also know that the spoofer, in this case, acts as kind of a repeater, which is basically telling all the ships in the area that they are located in Kaliningrad. If you want to read more, you can find the detailed report on GPS Patron. So enough about jamming and spoofing. We have a new hope. So we have been doing this research for some years now, and suddenly after the jammer showed up, media started also reporting on our research. So there have been some articles in famous news outlets such as Heise and Golem. So some people think that there's a very nice alternative. And then this article showed up. And I think we thought, okay, if Bild is reporting about your research, you should probably give a talk at CCC. So yeah, enough of that. We need a backup system. This is the bottom line of the talk. So we are depending on a single technology, which we can see now in the Baltic Sea region can be a hazard if we just have a single point of failure. So everybody would say, okay, we need a backup. I'm preaching to the choir if I say we need a backup. But what does a backup system need to do? First of all, it has to be somehow cheap or affordable. Maybe existing infrastructure could be used. It has to be easily operated. We have to somehow standardize it, use it internationally. And we also want a system that cannot be jammed in the same way as the current navigation system is being jammed.
Yes, and of course, ESA, the European Space Agency, had also a solution. They want to use satellites, not as high as GNSS satellites in a low Earth orbit, and they call it Celeste. To somehow combine it with the Galileo system, which is also a GNSS system, they said, okay, we make a role play. You see here, Galileo, an old man that explains Celeste, a young woman, how the world goes around. Nice. Basically, this constellation should consist of 10 satellites, so all through there's only one actor, and they start at around 160 kilometers, so quite close. And this means the signals are already 1,000 times stronger than from an original GNSS signal like GPS. They're choosing to transmit in the L, C, and K band. If you don't know what this means, doesn't matter. This is just what you choose to go through the ionosphere. So that's the only way you can basically get the signal on Earth. And the huge advantage is when you have satellites, you have global coverage. But why are we talking about terrestrial navigation then in the Baltic Sea? Because I have personally technical critique in this approach, because if you have 1,000 times stronger signal of a very, very weak signal, it's still weak. And if you look at the bands, you can still jam it and spoof it with this device, right? So for me, there is still a lag between, hey, we want to have another satellite system and we want to have high-power terrestrial signals where you need huge antennas and a lot of just material to actually interfere with the system.
Yeah, so why we have come up with a very different solution. So first of all, we don't use satellites. We put our system on the ground. It's a terrestrial navigation system. And, the initial motivation before this whole Jammer thing was that we wanted to create a civilian backup system because we identified a single point of failure. And we wanted to respond to small-scale GNSS outages, which can also occur naturally because, for example, of solar activity. And what we are using is existing maritime infrastructure. So one system that we are using is the very high frequency data exchange system, VDES, which operates in the very high frequency band, and the IALA MF beacon system, which operates at medium or low frequency. So we are talking kilometer waves here. We have been conducting this work as a team or with some few other people, this work since 2017, but initial trials have been going on since 2014 and 2015 in the Baltic Sea region. And our idea is simple. We want to create a system which provides backup, position, navigation, and timing. We want to provide resilience against GNSS jamming and spoofing in the Baltic Sea at first. And we want to detect GNSS interference, which is quite easy if you have a second system and the two systems diverge. One of it must be wrong. And also Bild newspaper copied our image. So I think they explain it quite well. And they did put a lot of work into just copying. Okay, yeah. So what we did so far, since 2017, we have teamed up with institutions from Germany, Poland, Denmark, Norway, Sweden, Finland, and Estonia. But we are also working together with colleagues in South Korea and Canada. Those countries are also rolling out the system now. And what we have done, we have established a pre-operational R mode testbed. So I didn't say it. The system is called ranging mode, R mode, sorry. And the testbed basically means that we have the existing transmitters and we use rubidium clocks and some newly developed signal modulators to provide a stable oscillator and transmit our time-synchronized navigation signals. And we have also developed dedicated receivers and positioning algorithms. We have been actively driving international standardization. And then suddenly a jammer showed up right in the middle of our testbed. So this is the story of our system. And we have nothing to do with the jammer. It's not marketing. And also Bild copied this picture from us. So once again, you can just find this picture in the Bild website.
Yeah, but how we plan to have this backup? The idea for us is that we don't want to waste a lot of resources for this. So we want to reuse existing infrastructure. And one of this infrastructure is the medium frequency beacon signal, which is basically a modulated signal. You see it here in the middle, but it's so narrow in the bandwidth that we can't do actually a nice ranging or timing synchronization with this. This is why it was suggested to just add two teeny-bitty continuous wave, which are really just the continuous wave signals, so a xenoid, and then they are all synchronized from the different station, and we estimate the phase of arrival where our receiver is placed. The problem that occur, we need a receiver. So the start was really, really hard. And first of all, we needed to see, okay, where we get the signals. We are scientists, so we just put a bunch of cables together, put it on a vessel, and drove to the Baltic. And what we saw is that we can get a quite good coverage, but obviously ranging with this in a large scale might not be the best idea. So we needed a plan. And the plan was to do this on software-defined radio basis. And then this is a pretty straightforward design. So you need a software-defined radio, some front end, depending on an antenna, a low noise amplifier, and a filter. And then we do all the processing just in a general purpose PC. However, especially in the beginning, we didn't have any stations available. We had one test transmitter that transmitted the signal, and somehow you want to test, okay, what I estimate there, is it the true? This is why we included also a GPS disciplined clock, which gives us just the frequency and time so that we can compare it to the transmitter and get an initial test of the system. So it's improving, right? You see in this cartonnage, there was the clock because they are quite fragile to temperature. You see also not very suitable to be used somewhere in the Baltic. On top, the beige box is our software-defined radio. Behind this is the computer. And then back then, we didn't have a front end, which might kill 1 or 2 SDRs. So finally, we want to make it mobile and do not want to connect every cable forth and back and so on. And the nice thing is, when we're talking about maritime and vessels, mobile is relative, right? So you can easily just place this rack and it will be mobile in a vessel. So we just use a lot of off-the-shelf components that we put together and put a quite large PC there with a RAID 1 configuration so that we can just collect as many as possible raw data. Because in the end, we want to go into our office and play around with the data to get the best results. The nice thing is now we can have a setup that we can just place on any vessel that's interested. We could do repeatable measurements, which is important. And we were able with this setup to do the first positioning in the Baltic Sea within the system, which is, of course, the first step to have a backup. We need to have positioning. And this is how it looks like. As Niklas already said, this is exactly where the first spoofing and jamming reports came in on the GPS jam side. And what you see here is basically poorly derived from the medium frequency system. And we were sailing with a boat using GNSS as truth, okay, because back then it was still working. And then we estimate our air mode track based on this time of arrival estimates. And during the day, we get a 95% accuracy of 12 meters, which seems a lot, right? But the vessel is easily 200 meters long, so these 12 meters are well in range of the standardization that we want to achieve. The only problem is with the medium frequency, during the night, we get an additional propagation path, basically a reflection at the ionosphere, and this will interfere with our signal, and we get worse accuracy. Then the 95% accuracy is around 63 meters. However, this would be still aligned with the standards of backup solutions for vessels. So we are in a pretty good shape for this. But we are not ready yet already, so we want to make it even more mobile and usable, and this is why we designed this small box. It's basically the software-defined radio, and put all the components that are needed beside the PC in this box so that we can just bring the box into the laptop and can basically do our backup solution anywhere we want. So now we need to talk a bit about the processing behind it. And because we want to have a very, very narrow estimation of this continuous waves in the medium frequency band, we just need to do a bit of math. What we're doing here is, you might heard from your math courses that you can do windowing when you want to do spectrum transfer. And what we did here is we just searched the optimum window. So we could just decide, okay, we want to have minimum noise in our continuous wave and improve this one way or another. So, not ready yet again, because the nice thing about software-defined radio, we can make it work almost everywhere. You might know the RTL SDR stick, just put some filter in front of it to protect it, which you can easily just solder at home, and this is able to get you a positioning. Or if you have an oscilloscope, because we are 300 kilohertz, most oscilloscopes are able to sample this, so you can just disconnect to your laptop again and do a positioning as well. So this is the nice thing about hacking, right? Just use what you have around and use it.
Yeah, so a very short story of wave propagation, which is also important because, as we already mentioned, our system, or the medium frequency system, operates at 300 kilohertz. So our wavelength is 1 kilometer, and a person outside just told me this is direct current. For some people, this may not even be alternating current. Our signals do not propagate only as line of sight, but we are also observing ground wave propagation. This means that our signal is following the curvature of the Earth, propagating along the surface of atmosphere and ground. And this propagation depends on the conductivity and permittivity on the ground, so you have to model it in order to really estimate the delay of the signal which we need for navigation in the specific target region. So how to model ground wave propagation? At first we used ground conductivity maps, which are provided by the ITU. You can see it in the picture above, and ground conductivity map is basically a PDF file. The German ground conductivity map is still split in east and west. And yeah, and you can also see that coincidentally the conductivity changes at the border between Poland and Germany. So this is what you get. It's of course not machine readable. That would be easy. So what we did, we developed a new approach to basically compute the ground connectivity and permittivity based on global harmonized data sets on soil texture. And then we used satellite remote sensing data that put together all the environmental variables that we need to know. For example, salinity of the Baltic Sea, soil moisture, surface temperature, etc. And you can put all of this together, compute a global high accuracy ground connectivity map, and estimate the delay of the wave by computing the electromagnetic field with an integral equation method. And then you get this very beautiful correction picture, which contains the information on the ground wave propagation delay, which is stored in the receiver and can be used to correct any additional delays. So a few years of research in one slide.
Yes, and because nowadays for researchers it's very important to do a technology transfer. We put all this medium frequency stuff in this small case, and this is also just able to bring it to a vessel and give out a positioning. But this was just half of the story, so
yeah. So if you might remember from the previous slides, there are two systems in use for R-mode. There's the MF R-mode that you just heard about, and there's the secondary system VDS R-mode, which is at higher frequencies, like 160 megahertz, and they are supposed to complement each other. So the first question, VDS, what is that? So the idea was to use an existing maritime infrastructure for R-mode. So the first idea that we had was maritime infrastructure, AIS, you might have heard of it. So that's a VHF system, so 160 megahertz, typically used to broadcast ship positions, and has 25 kilohertz of bandwidth. It's also pretty busy in most ports. So that's why we came to the conclusion, not an option. It's too busy, doesn't have the necessary bandwidth, not what we're going to use. So that's when the VHF data exchange system came in. It was recently standardized, so while we were working on this, basically, the communication system part has been standardized. It has 100 kilohertz of bandwidth and basically supposed to extend AIS and to provide more capacity to it. So that's what we're using there. I also want to share a kind of anecdote from standardization, as this is supposed to be a system that can be used everywhere. It's also standardized so that it's interoperable and you don't have these issues that you have with plugs when you travel. So VDS as a communication system is already standardized worldwide, so including Russia. However, the frequency allocation in the official table of what you can use it for says it's a communication system. So there might be the necessity to add that flag, we want to use it for navigation. And just to add that flag, you need to go to the World Radio Conference, which is held every 3 to 4 years. And to discuss it there, you need to put it on the agenda at the previous World Radio Conference. And that's after you convinced all the necessary people in charge that it makes sense to do that. So yeah, while we have done a lot in terms of standardization, there are also some interesting bureaucratic roadblocks along the way. However, that doesn't stop us from actually testing things. For our tests, we don't need to have a fully standardized system. I said earlier I'm from Munich. Where do you test boat in Munich? The answer is on Lake Ammersee. We were able to use the boat from the Wasserwacht there. Then we set up our experiment there. You have the location also again from the Wasserwacht. They allowed us to put our antenna and mast there. We have an SDR to transmit with an amplifier. We have 3 stations. They pretty much look similar. Each of them has this high mast with the antenna on top and also a GNSS reference for the timing. And of course the mobile part we put on a boat by the Wasserwacht. If any one of them is listening, thanks for letting us use the boat. What was the result of that thing? So the first thing we did is we estimated the ranges. It's in the name, ranging mode. But we also estimated Doppler shift that we got. So we can observe the relative movement towards the stations. That's what you see in these 2 plots, the range towards each station and the relative movement towards each station. Then when you put that into a tracking filter, you get positioning results. And we managed to reach around 10 meters accuracy most of the time at Lake Ammer. We're even able to track some fairly closely driven loops here, mostly because of the dynamic tracking with the Doppler observations. Now for armored on planes. I thought we were talking about ships. Yes, that's the idea, but a few years ago we had some colleagues come to us saying, like, hey, we're doing aerial observation flights, we still have payload capacity, are you interested on using the capacity? So the answer was not no. So what did we do? We had this nice motor glider that's I think stationed in Aachen, and it's operated also with DLR. You see it on the right, there's the payload. It's labeled with the 3D aerial camera, as that's the main payload there. However, you also see the small antenna in the top photo and the metal box in the lower photo on the right. That's where we put our SDR receiver. And we tested it right here in Hamburg. So we had 3 stations that were transmitting in this case. So one was at DLR. I mean, it makes sense to go to our own company. Then we had some help from Fraunhofer and also from the BSH, the Bundesamt für Seeschifffahrt und Hydrographie. So they also allowed us to use their very nice location directly at Landungsbrücken. So same evaluation again. We got the range and relative speed. You see the track on the left. They were doing this regular pattern for the camera mostly, but they also did some circles for us to track. Here's what it looks like when we've tracked it. So the red line is our armored result. For the planes, we only managed to get an error of about 200 meters. We're still working on figuring out what's the cause there, whether it's the different dynamic or whether we have some other things that we need to adapt for this use case. But with that said, back to maritime. We're currently building this test field. It's at the island of Rügen. And that's actually the first time for VDES at least, where we're using commercial hardware. So we have a partner from industry that are building base stations, mostly for AIS, but recently also with VDES, and they have the VDES armored as a prototype option in there to evaluate. So we've set that up here at Rügen. It also looks like this in a rack. At the top is the space station hardware, and the rest is our SDR for monitoring and a clock for the timing. And we also have some quite nice locations with these transmitter stations here. The third one is still missing. It's also supposed to be set up early of next year. And then hopefully we'll have a semi-permanent test bed for VDES armored as well. And with that, I'll hand over to Lars again for the conclusion.
Just in time to conclude the talk. You might already know GNSS is really vulnerable to attacks, intentional or unintentional. That's also an important point that we didn't cover too much because the talk was about the Baltic Jammer. This was the idea. And what we presented here in the last half an hour was the research work of 7 years. And not only of us, but also of a lot of other people. I have to clarify, we do do not have anything to do with the Baltic Jammer. So we just don't care about this, as you have seen maybe in the last half hour. And the nice thing about our system, AirMod, is that we use existing infrastructure. So there is no need to build new places, to build new antennas, and to build new infrastructure. And the system will be pre-operational in 2026, so next year. Why pre-operational? Well, we heard about how long standardization takes, and you can't do something operational until the standardization is done. And for me, the most important stuff about this is it's a civilian system. So it's not related to the military, and even smaller country can operate the systems on their own, so it's really independent. And if you're interested, we have a lot of stickers for the system, so just come to us and be happy to hand and discuss the topic with you.
For Q&A, if anyone has a question, we have microphones. They're labeled with numbers, and you already found one. Thank you very much. You're the first person to ask your question, if you want.
Well, thank you very much for the talk. So we have the same problem with AIS for some time. There's also spoofing experience, and I don't see, except of the frequency, what's the difference now? I mean, from an attacker side, it's more or less easy to adapt the attack, no? Or you don't do any cryptography, authentication, or at least I didn't hear about it.
So there's kind of two answers for this. The first answer is for the MF system, where it's just
for the MF, you need this antenna there. It's 21 meter height and just transmit one channel with a effectivity of around 80%. So to spoof this system, you would need 4 antennas of this that you need to place somewhere. But in general, every system is spoofable and jammable. That's also important to know. But for VDS?
Yeah, for VDS, there is some research by colleagues to make it authenticated, but for now, it's, as you said, not authenticated. Although with AIS spoofing, of course, talking about the communication system, someone just sending a message saying, I am here, and claiming that. So the other spoofing would be about the actual navigation system that we just talked about. And there, I mean, it has the advantage of, compared to GNSS, that you need higher signal power, it's more localized. But we are also discussing applications with the same technology that we use for this AirMod. It might be possible to actually locate an AIS transmission if you do the same thing in reverse. And you have 3 base stations that receive the AIS signal. You could try to locate the AIS signal's origin, which might help against that with more or less the same technology.
Mm-hmm. And maybe follow up, no? As a vessel operator, how does it look like next year? Do I have my navigation system?
You saw the small case. This is how it looks like then.
Okay. Thank you.
Sorry, I have to start prioritizing. We have a question from the internet.
Yes, the internet wants to know what's the maximum range of your base station.
Yeah, for MF AirMod, it's around 300 kilometers, depending on the transmitted power and the antenna used.
Yeah, and for VDS, as it's a higher frequency system, it's more or less limited to line of sight, so probably works well for around 20, 30 kilometers from the coast, maybe up to 100, but anything where you go beyond the horizon, it gets difficult. That's why it's more for adding in the coastal area.
Microphone number 2, please.
Yeah. In the US, they're also testing a system reusing existing radio towers. How does it compare to your solution?
Yes. So that's just a different infrastructure, and as the radio is constructed, they will not cover the Baltic Sea, as our system does, where the problem occurs. So this is a system mainly for the maritime, but it could be also used on land. And this NAB system, which I think is what you're referring to, is for the land-based systems. Of course, there are also other systems like LoRaN and so on. And in the end, we need a broad spectrum of solutions because this will be really resilient.
Thank you very much.
Another question from the internet, please.
Would it be possible to use a different time source than GPS, for example, DCF77?
DCF77 is actually not accurate enough because we need nanoseconds, and DCF77 is microseconds. But I think there will be in the afternoon a nice talk about time synchronization over network, which also can be quite precise. This is just an infrastructure problem. So you can, when we have fiber at the station, you can do pretty good time transfer there.
Microphone number 2.
Thanks for the talk. You talked about the ESA satellite approach before. I mean, we know that ESA is really, really fast in doing something. So do we expect something from them, or is this basically some idea which is discussed and just discussed?
No, they want to start it next year as well. So this is what they announced, and I would expect they're going this path.
Microphone number 2.
Hello. You said it doesn't require any extra infrastructure, and yet you are also setting up test stations to do this. So where does the system actually work in practice? And could I put it on a boat and sail it around the world, or would I have to rely on then other systems for that?
So currently you have to stay in those areas where it's actually active. So the idea of using existing infrastructure is to modify existing infrastructure. It cannot be used directly as is, but you don't need new locations, you don't need new antennas.
Thanks for the talk. Is any of this open source? Like mainly maps, I would be interested. Like
the code itself is not open source, but you can find our publications, and a lot of them are open access and also under open source licenses.
You mean ground connectivity maps?
Yeah, if there are available.
You're really interested in those?
Yeah.
Okay. Yeah, I think we'll find a solution.
Thank you.
Last question from the internet.
Really specific question. What's the biggest advantage of your solution compared to LoRaWAN-C?
Yeah, well, it works in the Baltic. LoRaWAN-C is outdated. The modern version would be eLoRaWAN, maybe also worth a talk. But the problem is the stations are even larger, and historical-wise, there's no infrastructure in the Baltic for this. So we don't see that this will be possible. All through, it's a better system in some cases.
All right. I have a tiny question for the audience. Who of you works at World Radio Conference? No. Okay. Maybe Bild-Zeitung? Okay. So if you know anyone, bring them together, because if they take or rework so much of your work there, maybe they can help you out with the conference thing. All right. Thank you so much for having this talk.
All right. Yeah, it was a pretty heady topic there. Comments or questions on that? Let us know, or anything else.
Well, it does bring to mind something. Yeah, I'm sure most of you guys are familiar with Whisper beacon mode.
Yep.
I don't know. I haven't watched them about 6 months now, but there's an engineer and a couple of guys. This guy decided he could figure out where Malaysian Flight 370 disappeared to, based on ham radio whisper signals, which are stored historically for, what, decade and a half, 2 decades now. And I just find that interesting too, that by using, it's not exactly what they were talking about, but the idea of taking the reports of different ham radio operators around the world and seeing weird anomalies and saying, okay, that was flight MH370 because we know its location was here and then here, and to be able to track. And they've done that, I think, with a couple of dozen other aircraft and known flying aircraft. And they tracked it versus the signals that they were with an algorithm tracking, and they were able to say exactly that they were tracking, I don't know, to the foot or to the mile or whatever, but they were able to track airplanes based on our whisper transmissions and receptions.
That is awesome. Yeah, I don't remember actually what came out of that. Tracking the MH370. If they, I mean, well, I don't think we actually have found it, but that's an interesting approach, though. Absolutely. Yeah. Yeah. Wow. Very cool stuff. Yeah. Anyone else? Yeah. Still have a few more minutes here. Q&A. Again, that was a pre-recorded video. Let's see some comments on there. Lighthouses on Gotland are now going to be equipped with Recon beacons. Swedish Maritime Authority is currently placing Recons on top of their lighthouses. That way you can find out your location by triangulation. Yeah, some more information here. So, yeah, comments or questions, anything else? Go right ahead.
Yeah, I found this topic to be fascinating. I think it's going to become more and more important as this type of technology and GPS spoofing becomes more widespread. I think that with a lot of conflicts in the world, this type of interference is going to become more and more commonplace. And so these types of solutions, I think, are going to be, they're very novel, but also going to be very, very, immediately applicable in many areas.
Yeah, if a pilot of an airplane or a ship doesn't know where they are and has life safety, and yeah, it's insane that it has gone on this long, and people still do see that, unfortunately. Yeah, some background as he was kind of mentioning there. Yeah, during conflicts, GPS spoofing is required for making sure that missiles don't end up where they were intended to, things like that. So, love it or not, it's kind of it's an option out there, and it's kind of a requirement. Yeah, anyone else though? Go ahead.
Well, like I say, I personally have experienced GPS spoofing, at 45,000 feet. And it's just, it's amazing that, I guess it doesn't take much of a transmitter to be able to beam up a 14 or, what is it, 1.2 gigahertz or 2.4 gigahertz, whatever, GPS frequency to send out false information. And you have to overpower the very weak signals coming out of the GPS satellites.
Yeah. It's that's interesting. Your weather balloons had experienced that. So yeah, I'd not heard that anecdotally, but it's crazy to see. Well, cool.
It'd be very interesting to know what the government itself has currently operational to overcome some of these difficulties, because that what they're doing is likely to be 2 or 3 generations beyond what is currently available to the consumer. So it would be interesting to know what else they might be doing. And I don't know if anybody else on this meeting has any other insight into that.
Actually, what they end up doing is anything the government's using, they use multiple different navigation systems, including a system that just it's just sort of an inertial navigation that just keeps track of where you were. And if suddenly the signals from various locations diverge, and they decide, okay, which one's the real system? So, yeah, it's any of the government, flying aircraft or whatever they're doing, they have multiple redundant systems to figure out what's going on, and they constantly compare them and say, well, this one's obviously wrong. So that's about all I can say about it. But it can happen. You know, I'm sure they're not going to, you know, the military as such is not going to tell you all the things that they're doing.
Yeah, the secret sauce may not be public potentially, but hopefully you would think that at least our government would take as much precautions as necessary to prevent spoofing. Yeah, absolutely. Well, cool. Yeah, that was just a brief talk from the CCC Club. Let me see if I can just bring up more information on them real quick here. Too many windows open. At least their YouTube channel, media.ccc.de. Real official channel of the Chaos Computer Club, operated by CCC VOC, c3voc.de for more information on them. Or that's the Operations Center. I'll have to try to find their actual page. Really great topics, though, if anybody's interested. Greenhouse gas emission date, EU surveillance laws. I mean, this is a lot of EU and Germany based, so there's a lot of tech and non-tech related. So, yeah, just more information on them. Yeah, 7:55. Let's see. Steve Riley says he thinks he does potentially know what some of the secret sauce is, but can't talk about it. So, or if he did, he'd have to kill us. Kind of a trope thing. Yeah. Let's see. All right. Well, again, this was a pre-recorded. We are always looking for presenters. Again, we have lists of, or we have, I guess, lists of people we have used before. We have tried to reach out to them and just haven't heard back from some of them. But if anybody has official or an unofficial talk with slides or no slides, we'd more than happy to have you. Otherwise, we can continue to play pre-recorded videos. Yeah, anyone else on that? Club business? Anything for Kevin Schmidt or any of the board members?
Daron, hopefully next month we'll have something on Meshtastic from one of our club members.
Perfect. Sounds good. That sounds good. I appreciate that. Very cool. Well, anyone else? Last minute comments or questions? Otherwise, we'll probably start to wrap things up. All right. Once, twice, nothing heard. I guess we'll wrap it up. Appreciate everyone being here. Anything last minute, let us know and we'll shut it down. Okay, well, next month, the third Wednesday of the month, it's going to be the 18th again, March 18th, third Wednesday. We will see you then. Join us at 6 p.m. for the Elmer session. We had a great turnout this evening. Can't thank everyone enough for participating in that. And then 7 o'clock for our meeting. Sounds like it's going to be on Meshtastic. All right, everyone, have a good evening.